Okay, so up until now, we've been looking at our trig ratios within a right triangle. So that means all of the angles that we've been looking at have been acute. Right? So what we want to do is to try to take what we've been doing and expand on it to where we can include obtuse angles. Right? I don't want to just limit myself to acute angles. So the way that we're going to do that is we're going to take an angle and put them on a coordinate plane like I have here. And we're going to look at coming up with a new definition for my trig functions. And that new definition needs to still encompass our old definitions. It's not like we're just throwing them out and starting all over, but those old definitions have to work within this new system. So we're going to go through how my formulas are coming to be, a little bit explanation on where these things come from. And I'm going to go through this rather quickly, because this is not something that I'm going to ask you to repeat on a test, but I think it's important that you understand how these things get developed. All right, so I'm given a point XY on a coordinate plane, and this angle that's in standard position we're calling theta. So I know that if I were to make a right triangle here, that this distance of this part of my triangle is X units long, and the height of this triangle is Y. Now, I'm going to call this distance here R, this distance of the hypotenuse, I'm going to call R. And if I want to look at how a formula for what R is, I can look at the Pythagorean theorem and figure this out, or I can use the distance formula. The distance formula is based off of the Pythagorean theorem. So I'm going to look at my distance formula. We normally have our distance formula to be D equals, right? And then we've got the square root of the difference of the X's plus the difference of the Y's. And both of those differences are squared. And this is based on the Pythagorean theorem. Now, we don't want to use D for distance. What we're going to do is call this R. And you'll see why a little later on here. This distance R is going to be X minus 0 squared, because this is the point 0, 0. So I've got X minus 0 squared plus Y minus 0 squared. So this is just going to simplify into X squared plus Y squared under the radical sign. What you need to keep in mind throughout this whole chapter is that R is a distance, so R is always positive. Does that make sense so far? Also, one thing is that this point P here that's on this line XY, it cannot be the point 0, 0, because then you just have one point, you don't have an angle. So we are going to use these three distances to come up with new formulas for sine, cosine, and tangent, and then cosecant, secant, cotangent. My sine theta has always been opposite over hypotenuse, but now it's going to be y over r, opposite over hypotenuse, y over r. So cosine of theta is normally adjacent over hypotenuse. So in this case, it's going to be x over r. Tangent of theta is normally opposite over adjacent. So y over x. But remember that you can't divide by 0, so x cannot be 0. Right? I don't have to have that caveat up here because I know that r is not 0. Then my next three functions, cosecant, secant, and cotangent, are reciprocals of these, which means I just take these fractions, turn them upside down. So this would be r over y. Here I have r over x. And here I have x over y. And we have to be careful of when these functions are undefined. Here, y cannot be 0. Here, x cannot be 0. And here, y cannot be 0. Right. So those are my new definitions that's going to hold true for any point that I put on this coordinate grid. And now I can have my point to be over here, down here, over here. I can have acute, I'm not limited to just acute angles. I now can have obtuse angles. Now, these are called your circular definitions, and they're on your reference sheet. Right? So you don't have to memorize them. But that's where they come from. They come from this distance formulas, basically. Okay, so let's look at an example. We're going to skip problem 1 and just go on to problem 2. So I've got this ordered pair, -2, 3. This is my x coordinate. This is my y coordinate. Right? So that means that this distance here is 2. But I'm going to go ahead and write this out like you're going to see it in most textbooks. I'm going to write this as -2. Now, I know that that length of that triangle cannot be negative. It's a distance, it's always positive. But I'm going to go ahead and write this out as -2. And I know that this height is 3. If I want to figure out this distance r, I'm going to use the Pythagorean theorem or use the formula that's on my reference sheet, which is basically the Pythagorean theorem shortened up, right? R equals the square root of x squared plus y squared. So R equals, I'm write down my formula, x squared plus y squared. So R is going to equal the square root of -2 squared plus 3 squared, that's 9, and 4, that's 13. Right? So R is the square root of 13. No. Any questions on what I've done so far? Okay, so I know what X and Y and R are. Let's say it again. That just sounded weird. I know the values of X, Y, and R. Okay. So now I can use those formulas that's on my reference sheet to find all 6 of my trig functions. So sine of theta, and remember now, theta is this angle in here. That's an obtuse angle. So the sine of that is y over r. So 3 over the square root of 13, bless you. And you rationalize the denominator, you get 3 times the square root of 13 over 13. Several of y'all struggled with rationalizing denominators on your test. You need to be sure that you know how to do that. If you have any questions, let me know. You come and see me during my office hours and I will help you with that. All right, cosine of theta is x over r. And my x value is -2. So I have -2 over the square root of 13. Rationalize my denominator. I have -2 times the square root of 13 over 13. And then tangent theta is y over x. So 3 over -2, so that's -3/2. Okay, the next 3 functions here are cosecant, secant, and cotangent, and they're just the inverses of these. So what I want to do when I'm looking at the inverses here, I don't want to look at this final answer that's where my denominator is rationalized. I want to go back to this original ratio and use that. And then when I take the inverse, flip it upside down, it's in the form that I need it to be in. It's supposed to be a 3, not a 2. And this is going to be negative square root of 13 over 2, and then this would be -2/3. On problem 3, I want y'all to find sine, cosine, and tangent. And then I'll do cosecant, secant, and cotangent for you. Find sine, cosine, and tangent. While y'all are doing that, I need to take attendance. Okay, let's first of all look at what R is. I think most of y'all were getting this right. R, you have -4 squared plus -6 squared. So R is going to be the square root of 52. And then you find the biggest perfect square that goes into 52, which is 4. So we're going to break this down into 4 times 13, square root of 4 is 2. So you have 2 times the square root of 13 for R. Any questions on how you figured out what R is? In your final answer, yeah. Okay, so sine theta is y over r. And so this is x and this is y. So y is -6 over r, 2 times the square root of 13. I'm going to simplify this part here. -6 divided by 2, that's going to give me 3 over the square root of 13. Rationalize my denominator. I get -3 times the square root of 13 over 13. Any questions with figuring out sine? Okay, so cosine of theta is x over r, and x is -4. So x over r. So I've got -4 over 2 times the square root of 13. This is -2 over the square root of 13. rationalize my denominator. I have -2 times the square root of 13 over 13. Any questions there? Make that negative sign look a little bit bigger. And then tangent is y over x. So -6 over -4, and that's 3/2. Any questions how I figured out sine, cosine, and tangent? All right, cosecant, secant, and cotangent are just the reciprocal of these. So cosecant, I'm just going to go ahead and give you the answer here. This is going to be the square root of 13, negative square root of 13 over 3. This is going to be secant here that I'm trying to figure out, and secant is going to be negative square root of 13 over 2, and cotangent is going to be, let me back up. The way that I got these numbers was just the reciprocal of those. Just turn these upside down, right? Turn this upside down. So here I'm just going to turn this upside down. So 2 over 3. Those are your reciprocal identities.